So, what are we doing today?
I have a review for, hold on one second, just trying to get into this website.
If it's helpful, I can go. You're going to Math Excel?
Yeah, no, I just got into it.
Okay. It might be better if I went into it and then we would both be looking at it. But, I mean, this is fine if it works for you.
I mean, you can if you want, if that would like help you. I mean, I only have like three assignments I need to do, and one of them I'm like halfway done with.
Okay. Are they all ones that you can verbalize? That's really the question.
Yeah.
Okay.
So the first
So I probably don't need to be on there. In other words, if it was some sort of an interpretation of a graph asking about end behavior or something, then it would be better if I was looking at it. Or in situations like that, you can always take a picture and send it to my email address.
Okay, yeah.
So if you get all of your problems off of that website, the best way to do it is to just let me log into the website and then we're both looking at
it. Okay. So the first one, it says divide 4 over 5 plus I.
Divide what?
4 over 5 plus I.
Okay. Now, have you and I talked imaginary numbers before?
Yeah, I think so.
Okay. So is this really a division problem?
I don't know.
It isn't, any more than if I were to say divide 1 by square root of 2, you don't actually do long division. What you do is you rationalize the denominator by multiplying this thing by square root of 2 over square root of 2. I can multiply anything by the number 1, that's the number 1, and it gives you that. And that's the answer. You didn't actually do division. If anything, you did 2 multiplications. Well, the same thing is true with imaginary numbers, is you cannot end up with an imaginary number in the denominator. It's fine to have it in the numerator, but not the denominator. Okay. So my goal here isn't to divide, it's to what I call realify the denominator. You turn the denominator into a real number by multiplying it by the conjugate. Okay, now, since I can only multiply this thing by 1, I got to do the top by that also.
Okay.
Erase some of the other stuff I have on here. Now, what do you get when you multiply 5 plus I times 5 minus I? Let's do the denominator first.
25 minus 5I and then plus 5I minus I squared.
These two terms are always going to cancel out. Okay? So you actually can ignore them when you're doing this process. I mean, as long as you're multiplying something by its conjugate, notice that that's the difference of perfect squares factored. That difference of perfect squares does not have any middle terms. So you can do these quicker by doing it straight away. It's this squared minus I squared. Now, I squared is a real number. What is it?
-1.
Okay, so now I got 25 minus a -1, which is the same as 26. So that's my new denominator. Now, what's my numerator?
20 minus 4I.
And there's my answer to that division problem. Again, we never did any division. We did just multiplication. And that's the way you handle it. And it would not have mattered if I have a, say, a plus 2i in the numerator. I'm going to do the same thing. I'm going to make the denominator real. All other processes with imaginary numbers. Can you still hear me?
Mm-hmm.
I think you might have lost me for a second. According to my program, it told me you did. With imaginary numbers, if doing anything else like adding or subtracting is a piece of cake. In other words, you just do it term by term. So that's equal to 2 plus I. In other words, 2i minus I is I. Okay? Multiplication the same way. Multiply it using the same techniques you multiply any binomial by. Still there?
Mm-hmm.
Okay. I heard a beep on my end, which usually indicates that you either just came on or you went off. But okay, so imaginary numbers, the only possible difficult thing is dividing by an imaginary number.
Really?
Uh-huh. All the others are super easy.
Okay.
But,
well, I typed in that the solution, or so like the end of 4 over 5 plus I, and it says, although your answer is equal to the correct answer, it is not in the correct form.
okay, let's stop a moment. What is wrong about that answer?
It's not simplified.
Exactly. I can divide everything by at least 2.
Mm-hmm.
So it's 10 minus 2i over 13. And complex numbers need to be in the format a plus bi. Okay? So I need to take this answer and separate it into 2 fractions. 10/13 minus 2/13 I. And now I have it in the perfect format of a complex number.
Okay.
Okay? Sorry about that. I didn't
really
need to stop with it. Yeah, that if you type this in, is this one of those things where you get 2 or 3 chances, right?
Yeah.
Okay. Did this work? 10/13 minus 2/13 I?
Yeah, no, that works.
Yeah. I didn't know whether they had requested it in a plus bi format or not. Even if they had not, in other words, I never want to give that answer because that can be simplified. I might occasionally get away with giving that middle answer if they didn't request a plus bi format. But if they requested a plus bi format, you always want to give it like that.
Okay. So the next one says solve 8w squared plus 18w minus 35.
Solve it by factor it, or is that equal to 0 and they want you to solve?
It's equal to 0.
Okay. So there's always a bit of a question in my mind on these kind of problems as to how much time I should spend trying to factor it.
Mm-hmm.
Because factoring is such a trial and error. There's not that many factors of 35 though, so it might be worth at least one shot to see if we can get it. What's the first step? What am I going to divide that 8w squared up into? Because the other choice, if I can't factor this, then I'm going to go straight into the quadratic formula and come up with the answer. So it's, you know, if I go straight into the quadratic formula, there's going to be 3 minutes of calculations to do. It might be that the first time I try to factor it, I'll come up with the solution. Let's try 4w and 2w. Okay? Now I know my signs have to be opposite, and the only factors of 35 that are going to work are going to be 7 and 5. I'll probably have to multiply that by 7, and let's see, if I did minus 7 plus 5, that doesn't work. But if I do plus 7 minus 5, that's not going to work. But if I do the 5 over here and the 7 there, now I'm getting the right number. In other words, if I try this, plus 5 minus 7, well, that gives me plus 10W in the middle, gives me minus 28W on the outside. Add those together, I get minus 18W, which means is I got the right number, I just got the wrong sign. Well, I can fix that really easy by making this minus and this plus. And now that's going to be the right answer. That's going to give me minus 10 in the middle and plus 28 on the outside. And so I've factored it. And now that we have factored it, how do I go from here? Now, whether or not that was faster than going straight into the quadratic formula probably depends on how good you are with your calculator. Because to go into the quadratic formula and solve this, you're going to have to square 18 minus 4AC. There's a lot of calculations you're going to have to put and do them in a calculator. But since it factored relatively easily, I'm now ready to solve it. I can come up with my solution in 2 seconds. What's the next step?
Set each 0 to 0, or I mean each.
Yeah, you cannot multiply two things together and have them be equal to 0 unless at least one of them is. It's impossible. You can't find two numbers that multiply together to give you 0 unless one of them is 0. So my next step is to set that equal to 0, which gives me W of 5/4, and set that equals 0, which gives me a W of minus 7/2. And there's my two solutions.
Okay.
And I don't know how. The worst thing about that Math Excel is you don't dare make one single error when you input an answer.
Oh, yeah, right? Like,
oh, it can be so frustrating. I once did calculus on that thing once with a student.
Oh, really?
And it was terrible just because of that, yeah.
Yeah, I bet. Like, I have a hard enough time. Like, I'm not even, like, close to as, like, gnarly as, like, calculus would be, but I feel like algebra is even, like, a little, like, challenging at sometimes because it's just on Math Excel.
Right. You might be able to come up with these answers really easily, but putting it in properly in the way that it wants is sometimes a little tricky.
Yeah.
But that's the way to do it. Now, before we leave this problem, since factoring, most people actually have quite a bit of difficulty with factoring, especially when you have a coefficient in front of the squared term. That's when factoring becomes challenging. Okay, so let's just make sure you can do it using the quadratic formula. Start with the general form of the quadratic formula. X equal what? Or in this case, W, would be what you would put here. The variable is W. So W equals what?
W equals negative 18, or do you want me to just do the...
I always love starting problems with the general formula, and then it's plug and solve. But if you always start with the general, you won't ever have any difficulty remembering it.
Okay. So then it's plus or minus square root of b squared minus 4 times a times c over 2a.
Okay. And in this case, a is equal to what?
8.
B is equal to what?
18.
And C is equal to what?
Negative 35.
Okay. So, let me point out the next biggest place where people will make errors. The inside is almost always, it's always that negative sign right there. And then for it to even be real solutions, C almost has to always be negative. Okay? So, I'm going to write 4 times 8 times minus 35. And I don't know if you can see how easy it would be to make a mistake, but all of a sudden now I'm looking at 2 subtraction signs maybe. So, but I'm not really. In other words, what I'm looking at is these 3 things are being multiplied together, and then I'm going to take the result and subtract it from 18 squared. And that's the way I would always recommend doing it. I wouldn't even attempt to put this into my calculator like this. Although, what do you have? You have the Inspire? What calculator do you have?
The TI 84, I think.
Okay. With that calculator, I would never attempt to do this in one function.
Really?
Yes. Just because there's so much, it's so easy to get it wrong, and they don't give you your feedback. They don't tell you what you put in. If you had a TI Inspire, maybe I'd try to put it in because they'll tell you exactly what you put in. But if I have to solve this problem, the very first thing I'm doing is multiplying 4 times A times C. Okay? Once you do that and you get a result, it'll be a negative number. So it's 32 times 35, and then you do everything else. You square the 18, you subtract that negative number, which means adding the number you got from here, and then do the rest of it. And you will come up with the same 2 solutions, which was W equals 5/4 and W equals minus 7/2. So it will give you the same solution. And you can see that in this particular case, it was probably a lot harder to go through the quadratic formula. I mean, we didn't even get through it yet because none of us did the calculations. The numbers are too big. But we can see that we're going to get a real solution. In other words, this part of the quadratic formula right there has its own name even. That's called the discriminant.
Really?
Yeah, and the reason it has its own name is because you analyze that frequently to see whether it's positive or negative. If it's negative, you're going to be taking the square root of a negative number and you're going to have a complex solution. Maybe you don't care about complex solutions, so you go on with the next problem. But if you discover that it's positive, now you know you're going to have 2 real solutions. And that's what we came up with, were 2 real solutions.
Okay.
So in this case, I would say easier to have factored it. But make this number 37 instead of 35. Now you could waste an awful lot of time trying to factor it before giving up. And once you give up, your only other choice is the quadratic formula. And so you might end up spending 20 minutes on a problem you should have only spent 5 minutes on if you'd have plugged it straight into the quadratic formula. So there's a bit of feel involved on these kind of problems as to whether you think it might factor. And since there weren't that many factors of 35, I thought it was worth a shot. make that number 24, and now there are so many factors of 24 that the trial and error process is going to take a long time.
Yeah.
So, but I'm glad we had this problem because it gave us a chance to go through both the factoring technique and the quadratic formula.
Okay.
The quadratic formula, you're liable to have to use that quite a bit. Even on the cubics that we worked on,
Yep.
cubic always comes down to a linear with a quadratic formula left over. And so you end up always having to factor the quadratic also.
Yeah. I don't know. We use the quadratic formula a lot, even this
Yeah.
next.
No, you do. That's why I say that it's good if you can recite that from memory quickly, because then it's just plugging in, as opposed to plugging in while you're trying to remember it. You know the difference?
Mm-hmm.
Yeah, and I think it's significant difference. Much easier to make a mistake if you're plugging in while you're trying to remember it.
Yeah, I do.
All right.
Okay. So the next.
Those two answers should have worked if you
no, that works good.
correctly. What else do we got?
It says use the quadratic formula to solve the equation 2x squared minus 3x equals 1.
Okay. Tell me how to do it.
You'll bring the 1 over first of all.
What's
Or it'll be
the general again?
Or wouldn't it be a minus 1?
Excuse me. Thank you. I wish I could say I was just testing you, but I made a mistake. What's the general again?
Minus b plus or minus the square root of b squared minus 4 times a times c over 2a.
Okay, now plug it in.
And then it's going to be 3 plus or minus a negative 9, or just a 3 squared.
These always turn out to be positive, because even if b is negative, when you square it, it becomes positive.
Okay, so it'll just be 9. Minus 4 times 2 times negative 1.
And I always recommend doing that step manually and take no shortcuts.
Okay.
Okay? In other words, always write it at least to there. Don't do any of this multiplication in your head. Just leads to mistakes.
Okay.
At least that's my opinion. I don't know. And it's all over 4.
Yeah.
Okay, now what?
Now, for the, let's do the 9 minus 4 times 2 times negative 1, and that would, so the negative 4 times the 2 equals negative 8.
No, don't. I would not suggest multiplying it in negative 4. Let's call that subtraction right there. And what we're subtracting is the 4ac. To me, that's the most safest way to do these.
Alright.
You could, I mean, I can understand why you'd multiply negative 4 by 2 times negative 1 and you'd end up with a plus, and that's fine. We're going to end up with a plus anyway. And maybe I'm being a little picky. I don't know. But the mistakes I always see people make is in carrying out this process. And that's because it's so easy to make a mistake doing that. It's easy to confuse this one with subtraction instead of the fact I'm multiplying it. And it's easy to get the sign wrong. So what is it?
And then, so it'd be
Plus or minus, what's the net?
9 minus a, or no, 9 minus negative 8.
Which is?
Just 1, or no, 17 over 4.
Correct. Now put it in A plus BI format. In other words, you need it to look like this. And it doesn't, oh, excuse me, this is not an imaginary solution. You don't need to worry about it. If it's a real solution, then this answer is as good as any.
Okay.
If it was an imaginary, let's say we had an I on the end of that, now you would want to put it into 3/4 plus or minus root 17 over 4I. And I know I cannot simplify root 17 because it is prime. You're never going to be able to simplify the square root of a prime number. All right. What else?
Hold on.
Yeah, don't put that I that I wrote in there. Let me erase that.
Is it 3/4 comma 17 squared over 4, or is it 3/4 plus or minus?
It's 3/4 plus or minus. That doesn't go away. And then you can turn that into a fraction by root 17 over 4. And I can't simplify either one of those. So that's what, in other words, and what that means is that one solution is 3/4 plus root 17 over 4, and the other solution is 3/4 minus root 17 over 4.
Mm-hmm.
So you really have to put it in like this. That's one solution. And here's the other one, 3/4 minus root 17 over 4. I'm not sure with your answer there whether it'll accept any of these combinations or what it's going to require.
Mm-hmm. All right.
Unless we made a mistake, that should be the answer.
Oh yeah, no, that one worked.
Okay, cool. Which one did you have to, did they allow you to put in the plus or minus like that?
Yeah, no, that was fine. Okay. They have like a little plus or minus button.
Okay, good. Oh, but they probably didn't allow you to put it in like that? What I have on top?
Yeah, they probably would have marked that wrong. I don't know.
Okay, that's good to know. Okay, that means we should always break that up into two fractions.
Yeah.
Whether it's complex or not. I was thinking that only the complex ones needed to be broken up, but.
Mm-hmm. Okay, for this next one, we have to find the vertex, the axis of symmetry, the minimum and maximum value, and the graph of the function. And it wants us to find the vertex first.
Yeah, when they wrote minimum maximum, it should have been slash, because there cannot be both.
Yeah.
Not if it's a quadratic. In other words, if it's a quadratic, it's going to have either a minimum or a maximum. What is the function?
X squared plus 10x plus 26.
Y equals?
Mm-hmm.
Now, what method, there's two methods to come up with the vertex. Probably the easiest method is minus b over 2a gives you the x coordinate of the vertex.
Mm-hmm.
Then, once you plug that in, you get the y coordinate of the vertex.
Mm-hmm.
The other way is to take this thing and put it into vertex form, which involves completing the square of these two. That's probably the easiest way in this case. Notice what happens. What's vertex format? General.
I don't remember right now.
A times x minus h quantity squared plus some k. And the reason that's vertex format is because h and k are your vertex.
Mm-hmm.
So if I can get this into vertex format looking like this, I'll be able to tell you the vertex immediately. Well, I'm going to rewrite this as this way. Put parentheses around there, leaving room to complete the square, and put my 26 over there. So far I didn't change anything, right?
Mm-hmm.
Now, how do you complete the square inside the parentheses?
I don't remember.
Okay, let's go through both of these. I would guess that that's something you're definitely going to need to know, either by the end of the semester or not. But you can't do conic sections or any problems like that without knowing how to complete the square. So let's certainly go through it. What you do, take half of this term here, the coefficient of the x term, and you square it, and you write it like that. Okay? Now I can change this function. So if I want to leave it the same, I got to go over here and subtract 25.
Mm-hmm.
Okay? Now it's exactly the same as it started. I have not changed it. The thing is that I can now write this as x plus 5 quantity squared. I can combine those to 1, and lo and behold, in one simple step, I've got it in vertex format. So where's the vertex?
-5 and 1.
Correct. What's the axis of symmetry?
-5.
It's x equal -5 because the axis of symmetry is a line. It's a straight line. In other words, now we're going to graph it. I would go to -5, and I'm going to draw a dotted line. It's an imaginary line that typically isn't drawn, but it's still a dotted line. And now I know that the vertex is at +1 right there. There's -5 plus 1. And furthermore, does it open up or down? If this coefficient is positive, it opens up. If this coefficient is negative, it opens down.
Okay, so does that mean it has a minimum or?
Yes, it has a minimum, and what is it?
A 1?
Yes, it's 1. It's y equals 1.
Okay.
Well, it's not really y equals 1, because y equals 1 is a line. That's a horizontal line.
Mm-hmm.
But you could say the minimum value on this function is 1. There's no way this thing ever goes below 1. So y is from 1 to infinity.
Okay.
Now, that was relatively easy. In other words, all we had to do was complete the square to come up with all 3 of your answers.
Mm-hmm.
Let's make sure we go through it the other way also. Because depending on how hard it might be to complete the square, it might be easier to get our answer by using the vertex being equal. First of all, the x-coordinate only of the vertex is equal to -b/2a. Well, what is that in this case? That's a relatively easy calculation also. So what's -b/2a equal to?
-10 over just 2.
So -5. So we instantly found the x-coordinate of the vertex by using -b/2a. Notice that that's the first half of the quadratic formula. Good thing to know. Because if you know this, you'll know the quadratic, and if you know the quadratic, you'll know this. Okay? So now that I have the x-coordinate of the vertex, I do still need the y-coordinate of the vertex. How do I get it?
Just plug that in.
So it's minus 5 squared plus 10 times minus 5. Again, I always recommend writing this as your first step. Don't try to do the calculations at the same time. There's my y coordinate right there. And now I can answer all three of these questions also. So it's a question of what is harder. It's a little more difficult to complete the square when there's a coefficient in front of the x squared because you have to factor it out. In other words, if this was my problem here, well, now completing the square, watch how much more difficult it gets. Just by having something like that, now I got to factor out the 2, and that turns that to 5x. I still got my 26 out here. I can only complete the square if the coefficient is 1. So no matter what this coefficient is, you got to factor it out before you can complete the square. Well, now I take half of 5. Now that's 2.5 squared is 6 1/4. Now how much did I add to the right side of the equation when I wrote that 6 1/4 in there? I added 12.5 because it's being multiplied by this 2.
Oh, yeah.
So I have to subtract 12.5 to balance it. So when you're completing the square where you had to factor something out, it makes it a lot more complicated and easier to make a mistake. But now we end up with x plus 2.5 quantity squared plus 13.5. Now I have it in vertex format. My vertex is at negative 2.5 and positive 13.5. So still doable. You just have to be pretty good with completing the square. It might have been easier to get these answers by using minus b over 2a. But you should be familiar with both methods.
Okay. Alright, so the next question says a rocket is fired upward from some initial distance above the ground.
Okay.
Its height in feet h above the ground t seconds after it is fired is given by h equals negative 16 t squared plus 112 t plus 2,720.
And the question is, how high up was it?
Yeah, it says what is the rocket's maximum height?
Oh, what is its maximum height?
Yeah.
Okay. We're looking at a quadratic, meaning that the thing's going to go like this. Okay?
Okay.
And maybe, in other words, that's projectile motion is a quadratic with a negative coefficient in front of it. And it doesn't really matter whether the rocket is launched like this or whether it's launched like this, straight up and straight down. It still is a function of this equation. So how can I tell where the rocket's height was to begin with? Use the second model or the first model here because it's easier to analyze mathematically or graphically rather.
Would it be the 2720?
Yeah, it's h of 0, right?
In
other words, time 0 is right there. This is the t scale. This is the h of t, height. So when time is 0, which is when the rocket is fired, you zero out both of those terms and it's always the constant.
Okay.
Now, to find the maximum height of the rocket, what is that? What is that point called?
The maximum?
Well, what is it of the parabola?
Turning point?
The vertex.
The vertex.
The vertex is the most important part of the parabola, no matter whether it goes up or down.
Okay.
Whether you're graphing it, analyzing it, no matter what you're doing, the very first thing you always want to find is the vertex. In this case, the vertex, the y-coordinate of the vertex, or the h of t coordinate, same thing, gives you the maximum height. Okay? So, we can either complete the square on this, and that's going to be harder, just because there's this big number here that has to be factored out, and that's a big number, and completing the square is going to be a lot of arithmetic.
Okay.
So I would say the best way to do this problem would be to use minus b over 2a, although that's actually a lot of arithmetic also. Remember, this gives you the x or the t coordinate. In fact, to be precise, that's t there, the t coordinate. What is it in this case? That's not too tough of a calculation.
The t coordinate?
Yeah, of the vertex.
Okay, so it'd be negative 112 over negative 32.
I think that is 3.5. What? You have a calculator in front of you?
I have one next to me.
You should really do these instead of me.
Okay.
That's positive 3.5. Okay? So, I can label that point on my curve. That's 3.5 seconds is where the height is reached after 3.5 seconds. So the question is, what is the height? Well, that means h of 3.5. Do that calculation.
What is that? What do you mean by that?
Well,
how do I do
glad I
that?
did it like this. Whenever you stick something in the parentheses, it means that that is to be substituted wherever you find t.
Oh, okay.
Remember when I did h of 0, I merely substituted 0 for each t, and that what's got rid of those two terms and left me with 2720.
Okay.
So now I want to do h of 3.5. That will give me this height right here, if I do h of 3.5. And this is actually an extremely important concept, especially if you ever take calculus. This concept of where you stick something in the parentheses of a function has this notation. In other words, the notation is the same as y. There's no difference. It's just the h of t is a little more robust. It allows us to figure out what h of some numbers are. And certain numbers are very valuable here. One of them is when h is 0, or when t is 0. It's useful to know what the height starts at. Another is when the t is the t coordinate of the vertex, and that'll tell you both when the maximum height is reached and what it is. But they didn't make this easy for us. They're going to make you plug in 3.5 for t and carry out that operation. What number do you get?
I got 2916.
How much?
2,916.
Okay. So that's what that is. And
Okay.
the only thing we know for sure is that it's got to be higher than 2720, right?
Yeah.
Okay.
But then after it asks when it hits the ground.
Exactly. Well, what is the height when it hits the ground?
2,916 feet.
No. Look at my picture here.
When it hits the ground?
It was fired from either on the top of a platform or the side of a hill or something. But when it hits the ground, it's talking about the ground being at height 0.
Yeah.
So, how do I solve that?
I don't know. Would you put in 0 or no?
or h of t. You don't take h of 0. You put in 0 for this because we know the height has to be 0 when it hits the ground. Now
Okay.
we have a quadratic to solve. In order to solve for t, I have to solve that quadratic. It's just like any other quadratic. Now, I would not attempt to factor this because it's pretty hard to factor. In other words, that might take me a half an hour to figure out how to factor that. So I would go straight into the quadratic formula.
Okay.
Even waste my time trying to factor it. What's the general?
Minus or opposite of b plus or minus the square root of b squared minus 4ac over 2a.
Yeah. And when I said the vertex was the first half, that's what I meant.
Okay.
Okay. Just to make it easier to remember either one of them.
Okay.
Plug it in.
It's minus 112 plus or minus the square root of 112.
112 squared.
Or yeah, 112 squared minus 4 times negative 16 times 2,720.
And again,
All over
right, sorry, go ahead. All over
negative
minus 32. Okay. Now, again, I'm always going to, my first calculation to simplify this thing is to do that part of it right there without the negative sign. I guess that's just my own personal preference. If you use the negative sign, it's not going to hurt you. It just turns it into an addition problem. In other words, if you were to multiply minus 4 times minus 16 times 2720, whatever number you got, it would be added to 112 squared.
Mm-hmm.
In the same way, this is going to be added to 112 squared. But if you want to put it into your answer, you're going to have to do this one right now.
Good.
And you may find an easier method of doing this on your calculator other than the one that I use, which is to do this, write it down, do that, write it down, subtract it, or add the two numbers, and then take the square root and proceed like that. I imagine that there's a place where you can input the quadratic formula in your calculator and just fill in A, B, and C, and it'll spit out an answer.
Mm-hmm.
I have no doubts that that function is available on your calculator. I don't know how to do it, but I used to have a TI-84, and my battery went bad, and it never came back on again, and I had to upgrade to an Inspire anyway, so.
Really?
Yeah. We know the minus b over 2a part, that's 3.5.
Okay, so I got negative 112 plus or minus 432 over a negative 32.
So, what's the time that it lands? Notice there's two solutions there.
Yeah.
Right? One of them's a negative number. One of them's a positive number. Well, guess what the negative number is? If I were to carry this thing back to the ground, that's what the negative answer is. It's a negative time. Well, there's no such thing as negative time, so we discard the negative answer. And we use only the positive answer, which gives us that point.
Mm-hmm.
but there are two x-intercepts. If you were to complete that parabola, there's two x-intercepts, or t-intercepts I should call them. And it's always only the positive one that you use.
Okay.
And the positive one is going to be this one right there. Minus 112 minus 432 gives you minus 544 divided by minus 32. That should be the answer, whatever that comes out to be.
Well, the 112 plus the 432 over the negative 32 came out to negative 10.
Right.
So yeah, so that would mean they're backtracking.
Right. That's the negative answer. So you get the positive answer by making sure your numerator is negative. And that's where I got this, by doing the negative part.
Okay.
You still need to convert that, simplify it. I suspect that that is...
Yeah, that worked.
Okay. Did you put the answer in and it was okay?
Yeah, it just worked.
Yeah, these are easy problems, but even when you learn how to do them, they make sure that there's plenty of math errors that can be made. I mean,
yeah.
Especially when they're using numbers this size, but these are real life numbers. This is always that, because that's from the effect of gravity.
Yeah.
And this turns out to be the speed that the rocket was launched from. It was launched at 112 feet per second, or whatever this was in. Yeah, meters per second. This is feet per second, and that's why it's minus 16.
Okay.
If it's meters per second, that number ends up being 4.9, I think, not 4.8.
Okay.
It's a physics problem. It's a classic physics problem. But it's also a math problem involving quadratics and parabolas. And it's just as much of a math problem. That's why it's... Because all projectile motion, whether you're kicking a football, a baseball, a soccer ball, or launching a rocket, it's all projectile motion follows a quadratic.
Yeah. All right. So
about 4 minutes. You got another problem we can maybe at least set up. Most of the time we're using here is to do those calculations, so I can probably get you set up on another one.
Okay, so this one says solve, and it has a square root, but there's a 3 to like the left of it, so it's like to the third power. So it's
that means the cube root.
Oh, okay, so it's a cube root of 9x minus 1 equals negative 4.
Okay. Like any equation, my goal is to end up with x equals something. Okay? So what steps do I need to take to isolate that x? What's the first one I can do? How do I get rid of that cube root sign?
Yeah, it's just you can cube both sides.
Cube both sides, exactly. Cube that side and cube that side. What's that leave on the left?
9x minus 1.
And on the right? Negative 64.
Okay.
Okay. 4 times 4 times 4 is 64, and the negative times itself 3 times stays negative.
Okay.
Okay. So now we get 9x equals negative 63, x equal negative 7.
Okay.
And you can have negative numbers inside of a cube root sign.
Really?
In other words, yeah, the cube root of negative 8 is negative 2. Why? Because -2 times itself 3 times is -8. And that's the definition. When you're talking square roots or cube roots or fourth roots or fifth roots, if you have an odd number, you can always put positive or negative numbers in it. If you have an even number, in other words, the square root could be written like that. But now I have to have only positive numbers in there if I want to avoid imaginary numbers.
Yeah. All right.
All right, Alex. I hope that's been helpful.
Yeah, it has. I was stuck on those like quadratic formulas for some reason.
That's a good one to get good at. So that you can immediately recite it and plug it in and handle it.
I'm also kind of like I kind of also need like a little more on the completing the square, so like that was also helpful.
Yeah, those are the end of Algebra 2 is where you get most of those. And the reviewing that stuff is going to be very helpful to you. So anytime I can be of assistance, I'm happy to.
Okay. Yeah.
All right.
All right.
I will talk to you next time, Alex.
All right. Sounds good.